Good afternoon. Welcome to AP Calculus AB. This is Tuesday. I didn't make a video yesterday because yesterday all we did was go over that practice AP test where, remember, before spring break we had the answers up here. And so there was no new material yesterday. Today, can I get the door, please? We're going over the Unit 6 test. By the way, here's a commercial for you. I gave this commercial yesterday. This is 5 steps to a 5 for AP Stats. So Zoe, you'll want to get this one. But also get 5 steps to a 5 for AP Calculus AB. Neither of these are required, but they're a really good idea to get these. So for the next 6 weeks, you can do extra multiple choice practice because we'll be doing a lot of practice in class. So for Calc AB, this is lower stakes. But for AP Stats, there's some good multiple choice review in here. That's one I recommend. You can buy that if you want. Probably $10 or $12. I don't know for sure. Let's find out. In fact, it's just an extra one. If I can find a way to give this extra one away. I don't even know where it came from, who bought it, who owns it. But if we were to search on Amazon, 5 steps to a 5, for AP Calculus AB, let's see if the thing even exists. 5 steps to a 5, AP Calc AB, called it $12. So, and you can get, you can sign up for 2-hour delivery, and a drone can deliver it. Probably break through these windows here and just bring it right to your desk. These are attack drones that can penetrate windows. 5 steps to a 5 for AP Calculus AB for the year 2019. So, thank you, William Ma, for putting that book together. All right, so don't forget to buy that. Now, what are the tests going to be looking at? Like, we've got the Unit 6 test we're looking at today. The test category, it's your first one for the semester. We're going to have a total of 5. 5 tests for the semester. So, Crystal and Cindy, this is news. You might want to listen to this. 1 of the 5 tests is now complete. 5. It's mind-boggling. What do we have? 1 test a week? Yeah. Well, but Unit 6. So far, we've had Quiz 1, Quiz 2, Quiz 3, and then next week on Thursday we have cumulative number 1. Cumulative number 1 can replace. Let's say on the Unit 6 test you got an 80%. Maybe on Quiz 1 you got 70%, 80%, 90% on Quiz 3. Suppose that on Cumulative 1 you get a 91%. That's next week, Thursday, block day of next week is the cumulative. And by the way, next week, Tuesday, both before school AM and after school PM, there'll be 1-hour review sessions for Thursday's cumulative. So you can come before school from 7 to 8 a.m. or after school from 3 to 4 p.m. There'll be identical review sessions. Come to one or the other. If you want to come to both, you can, but it's going to be identical material. Yes, go ahead.
Wait, aren't we taking the SAT next Tuesday?
Right, so the question is, isn't there an SAT thing going on next week? I don't know. I haven't looked at the calendar. What day is the SAT?
Next Tuesday.
I'm sorry, Tuesday? Okay, so we'll have to make our review session on Monday then. We'll go Monday before and after school so that we're not colliding with the, apparently there's an SAT or ACT or something. So that's fine. I'll move it to Monday. I'll let my other classes know. Appreciate that. So anyway, if you get a 91 on the cumulative, here's how that pans out. That means you can either have your 91 replace the Unit 6 test score if your cumulative is actually higher than that, or you could pick maybe 2 quiz scores. I'll do either one. You could either replace this with a 91 or both of those with a 91, and You'll have to do the math to pick to see which one is to your advantage. I'm not going to do the math. You do the math and let me know which one you want me to replace it with, okay? So that's how the cumulative is going to work for next week. Now, the other thing you need to know is that today we're doing Unit 6 test corrections. This is the first test where I've required test corrections before taking the cumulative. But that's what we're going to do today. We're just going to spend the day doing test corrections on Unit 6. By the way, so the third test of the semester will be a practice AP test number 1. It'll take 1 week because like on Monday we'll do the free response no calculator. On Tuesday we'll do the free response calculator. This is of the following week. And then on block day we'll do the multiple choice. I might put some of the multiple choice in on Monday and Tuesday so it's spaced out. And then we'll go over it on Friday. And that'll be a test graded on the 5, 4, 3, 2, 1 rubric that AP uses. So that means if you get a 70% or above on that AP test, so if you get 70%, I'll put it in as an A- into the grade book. If you want more than an A-, you'll have to get better than 70%. I don't know what the cutoffs are offhand for 4, 3, 2, 1, but I'm going to use the AP grading thing, which is a very generous scale. And so that'll be your, we'll take another week to do a second AP test. I mean, we've got 6 weeks to review, so we'll have time for this. And then the third practice AP test will serve as a cumulative to replace your low score on AP1 or AP2. So that means that even if you bomb the first or second practice test, the third one can be redemption for you. It can be your story of redemption. Winner.
What about our final?
Yeah, final exams are not required for students who take the AP test. As long as you take the AP test, the final exam is canceled. Is that nice? There's a project though we're doing after the AP test. But it's laid back, you're gonna love it.
Oh, is it Shrek related? Yeah.
So, what? Now friends, that's the plan for getting in 5 tests. 5 tests for the semester. Yeah, question, Eli.
Do the AP tests 1 and 2 or 3 target any chapters of the course specifically?
What they
or is it
do
just everything?
is it's the AP test which covers the whole course.
Yeah.
So now let's take a look at the test corrections for Unit 6. There was one problem that almost everyone missed, and since you're required to do test corrections, let's just do that one problem that almost everyone missed together as a class. And then I'll hand back the test and you can do the other test corrections. You're going to be required to turn in the test corrections on student supply paper. If you don't have a supply of student supply paper, you can go and borrow from the teacher supplied paper supply of student supplied paper. Go and grab that now. Everyone, let's write down the problem that almost everyone missed on the Unit 6 test. I'm just going to pause until we get ready to go here. And camera's on. Here we go, number 8. Now, turned out that, I have 2 or more versions for every test. It turns out that for the Unit 6 test, it was the first time that I gave my 4th period students one version, and then everyone in period 7 got a different version, which, might have been a surprise to some people. It's like, wait, what's going on? But problem 8 was missed by almost everyone. This happened to be a problem that was the same on both the 4th period version and the 7th period version. Didn't make any difference because pretty much everyone missed it anyway. So we had y equals 3x squared was one function given, and the other function given was y equals 4 minus x squared. And you were told to use the quadrant 1 portion of the region that's bound by both of those graphs. And wait, pause. We're back. Trust me, everything's okay. You were asked to find the volume by cross sections formed, basically the volume of the solid formed by placing semicircles perpendicular to the y-axis. We'll break this up in pieces. do me a favor and sketch the graph of 3x squared and 4 minus x squared, only the quadrant 1 portion of this region. Just kind of going through this together. Okay, I've got the graph of y equals 3x squared, parabola opening up, y equals 4 minus x squared, parabola opening down, y intercepts up 4. So it looks like it's just this region, and we're going to place semicircular cross sections on that region perpendicular to the y-axis. So one of the semicircular regions will have a base here, but let's call these points A, B, and C. Remember, semicircle is going to have a radius 1/2 of pi r squared. So the radius, I could tell some of you made the mistake of thinking that the radius of the semicircle corresponded to segment AC, but actually the radius of the semicircle corresponds to segment AB or BC. Basically, it's half of segment AC. Some of you forgot to multiply that by 1/2. And by the way, if you visualize all n semicircular regions, the wheel on the 4 minus x squared track, if you will, has to jump from the 4 minus x squared track onto the 3x squared track. That's an indication that this setup only problem was a 2 integral problem. If the camera is blocking your vision, just move to a different seat so you can see what's going on. So this was a 2 integral problem. So we're going to call these points D, E, and F. And since it's a 2 integral problem, you're going to need to do the algebra to find the coordinates of this point of intersection. So take a pause now, do the algebra to find the coordinates of this point of intersection. I'm going to pause the camera. You do the same if you're watching at home, or on a train, a bus, or a plane. We did the algebra. We said 3x squared equal to 4 minus x squared. Solve for x. We got positive 1. Since we're in quadrant 1, we took the positive square root. When x is 1, y is 3 on both curves. Okay, so what we're looking at here is, here's another feature that, I don't remember anyone actually doing this, but if you draw the ith semicircular region, where points A, B, and C show up in both diagrams, the dy in the first diagram corresponds to the dy in the second diagram. And we could call r sub 1 sub I, 1/2 of segment AC. So it'd be a good idea to set up another semicircular diagram that features points D, E, and F. We could call segment DE R sub 2 sub I, and do a 3-colon analysis on R sub 2 sub I, which would be half of segment DF. So I'm going to pause the camera again. I'd like you to complete the analysis, find a mathematical model for R sub 1 sub I, and a second mathematical model for R sub 2 sub I, 1/2 the length of segment DF. Pause in the camera. You may continue. Right, most of you are still working. So I'm going to work here at the board while you're working at your seats. I'll try to be quiet so that when you're done, you can just peek up here to see if we agree. All right, I feel like I'm getting some traction on this problem. My analysis for segment AC, using right minus left, segment AC would be the x-coordinate of point C minus the x-coordinate of point A. X-coordinate of point A is 0, so all I really have to focus on is x-coordinate of point C. And this analysis is really helpful because it gives a call. It sounds a clarion call for this equation to be solved for x. Y minus 4, the opposite of y minus 4 is 4 minus y. So x is plus or minus the square root of 4 minus y. But since we're in quadrant 1, I'm going to take the positive square root. So the x-coordinate of point C is the square root of 4 minus y. The 1/2 carries through. And down here, the x-coordinate of point F, by solving this equation for x, is the positive square root of y over 3. Any questions on how to obtain a mathematical model for r sub 1 sub I, or a mathematical model of 1/2 square root of the fraction y over 3 for r sub 2 sub I? All right? And then, oh yeah, if you have your phone, yeah, go ahead and put that away. You can put it away permanently by just cutting a little slit into your backpack, sliding the phone in, and then sewing it up with needle and thread. Cancel your phone plan. Save a lot of money. Yeah, go ahead.
No,
Oh,
I was just
yeah.
making sure I had that.
So let's take it from here to then the volume. We're going to let V represent the volume that's described in this problem. And see if we can do the setup. Volume by cross sections. And again, I'm going to pause the camera while you work on the integral setup. Friends, I'm not putting the final answer up here yet, but let's talk structure. Both integrals have a pi over 2, because it's pi over 2 r squared. One of them is going to go from, I hope you put dy. Every representative rectangle should be labeled with either dx or dy. Labeling it with dy indicates that we have to focus on the y coordinates. We have a journey from 0 to 3, so one of them is going to go 0 to 3 of something dy. The other integral is going to be pi over 2 times the integral from what to what of something dy. Who can give me the limits of integration on this one? Some of you are saying 3 to 4, which is correct. Okay, so that's a skeleton of the integral setup. I'm going to pause the camera again, see if you can finish it from there. Okay, let's talk. Off camera, I mentioned that the fraction 1/2 appears twice in this problem. Semicircle is half a circle. So this 1/2 right here is because the semicircle is half a circle. That 1/2 is because the radius is half of a diameter. So here's what we're looking for. We're looking for the radius from 0 to 3. That's df, that's r sub 2 sub I. So that's 1/2 square root of y over 3, that quantity squared. Many of you on the test, you forgot to square the 1/2 in here. So a lot of you had the 1/2 half out front, but you skipped this 1/2, which when squared becomes 1/4. 1/4 times 1/2 is 1/8. So there's a 1/8 out here. Oh, and then times 3. 1/24. Anyway, this one, this guy from 3 to 4, that's a r sub 1 sub I. So it's going to be 1/2 times the square root of 4 minus y, quantity squared. Now, that was part A of the problem. Part A was just the integral setup. Part B was to type it into the calculator. I'd recommend not trying to type that into the calculator because there are some nice simplifications you can do, low effort simplifications before going to the calculator. I wonder if my calculator's turned on. I'm going to start turning it on right now. It takes a little bit for that application to open. But friends, don't go to the calculator yet. First, let's call this 1/4 times 1/3 is 1/12. Let me pi over 24. We go from 0 to 3 of y dy. That's a nice simplification because when you square a square root, it's just going to be y over 3. 3 times 4 is 12, and 12 times 2 is 24. So that's the first integral. The The second one is gonna be 1/4 times 1/2 is 1/8. Pi over 8, integral from 3 to 4 of the quantity 4 minus y dy. That's an expression that will type easily into your calculator. So do the keystrokes, take out your calculator now. The standard on the AP test is 3 decimals. If you don't have a calculator, approach me now with the phone. Let's get the thing typed in and round it to 3 decimals. How are you doing on your calculator skills? I typed in pi over 24, math 9 of y, 0, 3, plus the second integral, pi over 8, definite integral 4 minus y, 3, 4. Of course, using the letter x or w would produce the same result. So 0.785. The AP test, don't write 0.78, don't write 0.79, 3 decimals. You can actually write more. You can write 0.785398. They'll give you full credit, but you can't give less than 3. Gotta have at least 3. Round it to 3 to be safest, but they would accept. Okay, I'm just gonna pull this into the document. In case you're wondering what the connection is between the calculator work and the written work. Any questions on how to knock out the solution to problem 8? Okay, we're gonna spend the rest of the time doing the other test corrections. Test corrections are due on Thursday of this week at the beginning of class, and you can take your Unit 6 test home with you, so you can, in case you don't finish a class today, you've got about 48 hours to knock this out in the luxury and comfort of your own home. Thanks for coming today. You are